Project Tango is Google's effort to build a smartphone with the ability to create complex, accurate 3D models of the physical world. With the potential to change the interactions between humans and machines, this is the stuff of science fiction. So it's not too surprising that the groundwork for Tango actually started in outer space. Mars, to be precise. The 3D mapping and tracking technology that powers the Project Tango prototype comes in large part thanks to the work done in the Multiple Autonomous Robotic Systems, or MARS laboratory, of Professor Stergios Remiliotis at the University of Minnesota in Minneapolis. 10 years ago, Remiliotis worked with NASA on perfecting the technology to help robots land on Mars, utilizing a system called Vision-Aided Inertial Navigation System, or VINS. But when the funding NASA had earmarked for further VINS research was reallocated, Remiliotis needed to find a new application for the 3D mapping tech. A few years later, 3 of Remiliotis' students at the university, Joel Hesch, Dimitris Kotas, and Sean Bowman, found a new use for VINS that would refocus the Mars Lab's sights from the red planet to the palm of your hand. The students ported the system to a laptop connected to a camera and an inertial measurement unit, or IMU, a motion detection gizmo containing 3 accelerometers and 3 gyroscopes, hardware that also happens to come standard in just about every smartphone on the market. Using VINS, the laptop could render a 3D map of an indoor environment in real time. Soon after their success, the lab wrote a proposal to the National Science Foundation that looked to use mobile devices to map public places like airports, universities, malls, any place that a traditional GPS wasn't much of a help. Now, work done in the Mars lab provides the foundation for Google's Project Tango. Google has awarded a $1.35 million grant to the University of Minnesota for the lab to continue its research into fast and accurate 3D localization and mapping with a mobile phone. The transition from working with NASA-ready equipment to the tech that fits in your pocket has been dramatic, at least where the cost of research materials is concerned. According to Remiliotis, the old IMUs he utilized in his research cost hundreds of thousands of dollars. Quite a contrast now that the IMUs that come in your smartphone cost only about $1. The 3D mapping app built by the Mars Lab runs on smartphones you can buy right off the shelf. The one we tried at the university's Walter Library was a Samsung Galaxy S4, and it's remarkably easy to use. Once activated, the user holds up the phone and walks around, just like you would when shooting a video. As you walk, the app traces a line that's superimposed over the running video on the screen. The line represents trajectory, while the pyramid moving all about the space represents the direction in which the camera is pointing. Professor Remiliotis explained that this is full-scale 3D in places where you don't have GPS. It's something that's always been extremely difficult, requiring powerful desktop computers, but these days it can be done on an ARM processor. Meanwhile, Google's Project Tango prototype builds on the app created by the Mars Lab. The prototype device itself is thick, presumably to accommodate a bigger than average battery. It also seems to sport 2 cameras. We say seems because Remiliotis wanted to be sure that he didn't break any NDAs during our conversation. Even without the professor's confirmation, it seems logical that a 3D mapping smartphone might be aided by 2 cameras working together, rather than just one. After all, the brain's ability to capture stereoscopic imagery and depth information is helped quite a bit by the fact that we've got 2 eyes. Google's Project Tango app provides a side-by-side view of the actual environment as the camera captures it, next to a 3D rendered environment that's pieced together as you walk. It seemed like the same app as the one demonstrated on the Samsung, but taken to the next level. And considering that the Project Tango prototype is armed with an advanced computer vision chip from Movidius, that's not much of a surprise. As well as Project Tango works now, Google, the Mars Lab, and the rest of the project partners are still trying to tackle a few big problems. One, explained Remiliotis, is regarding robustness. That is, making sure that the phone and the app are resilient enough to keep working despite users dropping or shaking their devices. They're also trying to push the boundaries of what can be done with a smartphone in terms of how large a space you can map. Remiliotis says that it's his dream to go to the Mall of America, just outside of Minneapolis, and map the interior. And since the Mall of America can fit 7 Yankee stadiums within its walls, no one could accuse him of not dreaming big. The Mars Lab has high hopes for how its VIN system will be used. Applications like photorealistic 3D mapping, assistance for the visually impaired, more immersive training programs for new employees, and augmented reality in games. And, interestingly, Project Tango will have some applications more in line with its star-bound origins. 2 Project Tango handsets will be launched on the upcoming Orbital 2 space mission, scheduled to head up to the International Space Station this May. It's only fitting that technology originally designed to guide robots landing on the surface of Mars should finally find its way into space.